Find the relative extrema of y equals x cubed minus 6x squared plus 9x plus 1. Well, what's relative extrema, you ask? I got you. That's a cubic. This is a cubic. This is going to look something like that, give or take. Who knows exactly what it's going to look like. But extrema stands for maximum or minimum, or both, depending on what you're dealing with, or multiple. The reality of having a cubic function that looks something like this is this guy's going to continue going up and to the right forever and ever and ever. This guy's going to continue going down and to the left forever and ever and ever. And if someone's like, what's the maximum? Well, it's going to be infinity and infinity. What's the minimum? Infinity and infinity in the negative territory. Relative extrema says, all right, well, let's pretend that that's not going on. Tell me where this thing peaks out and bottoms out, ignoring the fact that we have forever going on the left and the right. Where it peaks out is called the relative maximum. So I'll just say rel max. Where it bottoms out is the relative minimum. Now, the way we're going to use calculus to figure this out is we're going to find where our equation is increasing and decreasing. When we find out that our equation is increasing and then decreasing, we have ourselves a relative maximum. When we find out where our equation is decreasing and then increasing, we have ourselves a relative minimum. So in order to find increasing, decreasing intervals, we need to first go with critical points, which requires the derivative. So let's start out with that. The derivative of y prime, is going to be drop that 3 down, make the cubed a squared, minus 6x, drop down the minus, 2 times 6 is 12, x squared becomes x, and then 9x becomes 9. Excuse me. All right, so critical points. Set that guy equal to 0. Okay, so I'll put CP, not for Chris Paul, but for critical points. If you're watching this video and you're learning calculus, you probably don't even know who Chris Paul is. I want to factor this guy out. Let's bring out a 3. X squared minus, let's see, divide a 3 from that gives me 4. Divide a 3 from that gives me 3. Let's keep factoring. 0 equals 3 times, let me think, 2 numbers that add up to -4 and multiply out to +3 are going to be -3 and -1 in no particular order. Now, if 0 equals a bunch of factors multiplied together, I can use the zero product property and set each factor equal to 0. So 3 equals 0 means nothing. X minus 3 equals 0 means that I will have plus 3, you get 3. If I have x minus 1 equals 0 plus 1, you get 1. So my critical points are going to be where x is 3 and where x is 1. This is where my line should change from increasing to decreasing, decreasing to increasing, so on and so forth. So I'm going to make myself a little sine table, sine graph, whatever you want to call it, SIGN. I care about 1, I care about 3. Okay, and this is going to be my y prime sine graph. Now what I'm going to do is this is going to tell me which intervals is increasing or decreasing. I'm going to pick numbers inside each interval. So -infinity to 1, I can pick 0. 1 to 3, I can pick 2. 3 to infinity, I can pick, 10. And if I take these numbers, plug them into the derivative, and get a positive, it's increasing. If I get a negative, it's decreasing. So let's plug in 0. Y prime of 0 is going to equal 3 times 0 squared, which is 0, minus 12 times 0, which is 0, plus 9, which is a positive number. So this guy is increasing. Okay, this cubic is increasing from -infinity to +1, then hits a horizontal tangent and maybe does something different. We'll see. Let's plug in 2. Y prime of 2 is going to be 3 times 2 squared, which is 12, minus 12 times 2, which is 24, plus 9, negative. So this is decreasing. If I plug in 10, and again, I don't know why. I chose 10 because it's large enough where I should obviously tell if it's positive or negative. 3 times 10 squared is 3 times 100, so 300, like that movie. I forget what it's called. Minus 12 times 10, which is 120, so minus 120, plus 9 is definitely going to be positive. So when x equals 1, it goes up and then down. So at x equals 1, I have a relative maximum. At x equals 3, it goes down and then up, which means my graph is bottoming out. This is a relative minimum. Now, let's find the exact points. Okay, the way I find the exact points is I take those critical points that gave me a relative maximum or a minimum, and I plug them into the original equation. So I'm going to plug in 1 to the original equation. So y of 1 is going to equal 1 cubed, which is 1, minus 6 times 1 squared, which is minus 6, plus 9 times 1, which is 9, plus 1. So 1 minus negative 5. Negative 5 plus 9 is 4. 4 plus 1 is 5. So when I plugged in 1 to the original equation, I got 5. I'll deal with that in a minute. Well, no, I'll deal with it now. That tells me that my relative maximum, just one of them, is going to be the point 1, 5. Let's find out what my relative minimum is. All right, we'll plug in 3. So I have y of 3 is going to equal 3 times 3 times 3, 27, minus 6 times 9, so minus 54, plus 9 times 3, which is 27, plus 1. All right, so it's 27 plus 27 is 54, minus 54 is nothing, plus 1 is 1. So that equals 1. So my relative minimum is going to be 3, 1. Look at that. Didn't have to erase a thing. Aerosmith said, I don't want to change a thing. I said, I don't want to miss a thing. It's, I don't want to miss a thing. All right. This giant boot is my answer. Have fun with that.